It's quite difficult to get into places like this. I have to remove everything metallic. I'm not even wearing a belt. I'm a bit worried that my trousers might fall down. That would be a first for periodic videos. I'm really excited. I've got here more than £1.5 million worth of platinum group metals. Never had so many in front of me all at once. And we're here at Johnson Matthey Noble Metals, and they've allowed us to see all sorts of parts of the factory, but just to warm up. As a sort of sideshow, we have here 5 kilos of gold and another 5 kilos in a packet. These are each worth £150,000, so reasonable house just to get started. We're here at a place where they are processing these metals here, rhodium, iridium, palladium, and platinum. And the reason that they're called noble metals is that they don't react with oxygen easily. In fact, platinum is one that really, even at high temperature, doesn't form oxides. The other ones can form oxides. Gold doesn't form oxide. Gold is over here and is close to these, but is not normally considered a platinum group metal. Noble is an old-fashioned word meaning it doesn't react. Posh way of saying chemically boring. The noble gases, they didn't think reacted with anything. Now they know some of them do, but noble is dismissing them as being worthy but boring. The important thing about the noble metals, the platinum group metals, is they're fantastic catalysts. They can be used for all sorts of applications, making nitric acid, cleaning up car exhausts, and many other applications. So, of course, in all this processing, they generate dust. And most of it's caught, but some of it you can't avoid going into the air and falling to the floors. So some of it collects on our shoes. So when you go in and out, they have special brushes to clean the bottom of your shoes, and they recover really quite a large amount of metal each year, worth more than a decent-sized car. What they're doing in this factory is taking this material, which is called sponge, which is what comes from the mines. This is platinum sponge here, and in this bottle here is rhodium sponge. And it's much finer because rhodium is the last element to come out of the process in the mines. So they take this sponge and turn it into grains, rather like this. Here are grains of platinum. This is probably the only time in my life that I will be able to play with platinum in such a casual way. And over here, I'll use the other hand so I don't mix them up, are similar sorts of grains of iridium, but they're very much heavier. They turn this sponge into those grains by heating it up to high temperature, melting it, and then pouring the molten liquid out. And it's fantastic. You see this liquid that's so hot, it's bright red, and then it's cooled down rapidly to form the grains. And then the grains can be taken and melted and cast into an ingot, a large lump. And here we have an ingot of platinum. This weighs 13 kilos. And you can see I can't lift it up with one hand. With two hands, I can just about start lifting it. The difference between this and gold is that you can use platinum as a catalyst for all sorts of chemical processes. So ingots like this are then turned into bars, like so. First of all, by hammering the ingot very hard with a heavy hammer when it's really hot. And the fantastic thing is, as it hammers it, the metal gets hotter. The energy of the hammer is turned into heat. It starts glowing redder and redder. And then they take the hammered bar and draw it down through a series of dies. So it first of all gets into a coil like this. And as the coil comes out of the die, it coils itself up. It's almost like magic. You see this coming out and going round and round and round. I was mesmerized. And then they take this heavier bar and put it through a series of dyes till, in some processes, it gets narrower than my hair. I didn't actually take out a hair to measure, but I believed them. And I couldn't see it easily, though Brady is much better with his lens and saw it. Once they've got these fibers, these wires, they can then start making all sorts of materials. They can knit the fibers together or weave them, just like you do with cloth, to make fine meshes which are used in the chemical industry for catalyzing reactions, particularly, for example, turning ammonia into nitric acid. This process that we've all read about in books, ammonia going to nitric acid, but actually to see these huge pieces of fiber woven together. And what's so interesting is that they're so thin. You imagine when you see a huge chemical plant that it's full of catalyst, whereas in fact the operating catalyst is really quite thin and the reaction takes place very fast, and you need the rest to warm it up and cool it down afterwards. It's important to stress that in the mines for the platinum group metals, and the main mines are in South Africa, in Russia, some in Zimbabwe, and some in Canada. In all these places, the amount of platinum group metals in the rock is very, very small. To make an ounce of this sponge, you require somewhere between 10 and 40 tons of rock, a huge amount. And the other thing is the processing is not instantaneous. Once you've got the rocks out, to get the platinum material takes about 6 weeks of processing, letting things settle, processing some more. And rhodium takes another 14 weeks, so perhaps 20 weeks, nearly half a year to get the rhodium once you've dug the rocks to this stage. But once it gets here, they can process things really quite quickly. Some of the samples when we arrived are already being processed. Had to get us another ingot of platinum. The one we saw was already gone into the factory. 94% platinum and 6% rhodium. And part of the reason for this is that rhodium is a much rarer element, and also that people have found that platinum with a bit of rhodium gives particularly good